Hi friends, is my voice is audible to you? If my voice is audible and if everything is fine, please let me know. So, I hope you are feeling well and everything is fine. Hope you are enjoying the sessions also, right? Yes. Let me have a look, quick look. If you are in online, please say hi so that I will also understand. Okay. So coming to today's session, one second. Yeah. Is my voice is audible to you? Hi Vasan Sai, hi. Is my if my voice is audible to you, please say hi. Okay? Yeah, yeah. I hope my voice is audible to you clearly. Right. And everything is working well. Right. So yes, guys, very good morning to all of you. Hope you are fine and you are enjoying the sessions also. Welcome to India's largest online e-learning platform, Unacademy. How are you guys? Hope you are fine, right? Okay, before I today's session is all about second part of columns. I will try to complete the columns today, right? And before I start the session, I want to say big hi to all of you, and I can recommend you guys. There are so much of free content is already happening in this Unacademy learning app. So if you didn't install this Unacademy learning app till now, I can recommend you guys to install this Unacademy learning app, right? And if you want to follow me in Unacademy Learning App, use this link given, which is given below. After you install this Unacademy Learning App, if you are able to use this link, you are able to follow me. When you are able to follow me, three things are there. Like the first and foremost thing is the free content that I had already done for free of cost in Unacademy Learning App that you are able to access. The future coming free special classes of mine will be notified to you. That's the second advantage. Third advantage is at the end of each and every special class, we will provide generally a PDF notes. That is also you are able to get the free of course. All these are you are able to get even without paying a single penny. That is one thing. Right. Some people say like, sir, is there any paid course, complete detailed paid course is there in an academy for any competitive examination, especially for GATE and ESE in an academy learning app. After you install this Unacademy learning app, select this is the goal. Select the goal as GATE and ESE. After you select the goal as GATE and ESE, and you go to plus courses in the main drop down menu. Plus courses. When you go to plus courses, after you press this, there is a tab called get subscription. When you press this get subscription, it will ask you, is there any referral code is there with you to get discount? Yes, you can use this referral code VT10 to get 10% discount. Apply this code VT10 to get 10% discount. When you go to subscription, there are actually two courses are there, brother. The two courses that are there are, one is iconic course. Second one is plus codes. Iconic course is some bit different from plus course. In this iconic course, additional features in addition to plus is you will have a personal mentor will be there. He will resolve all your doubts regarding your subject. That is one thing, right? And in iconic course, you will be provided with a top quality of notes from an academy directly. So these are the two things where you have in iconic. Whereas in case of plus courses, generally I can say like first and foremost is there is a support, instantaneous instant doubt resolution is possible, and second one is with the support of test series is also possible in plus, and there is no need to plan yourself. All the courses are structured courses, and when you are able, you will be there is there all the courses are structured courses. That is the third advantage. And coming to the fourth advantage, you will be provided unlimited access to the recorded versions and even the live sessions within the duration of subscription. These are the four advantages when you have taken plus, brother. So making all these advantages of plus and iconic together, you are able to crack any sort of competitive examination with very good rank. There is no doubt about that. Some people will say like, sir, this is my first class. Can you please introduce about yourself? Yes, I am Venkata Tilak Uppalapati. People call me as Venkata sir. Some people call me as Tilak sir. I completed my master's degree from University of Sheffield, England, and about to complete my doctoral degree, which is PhD also. My background of education is completely into structural engineering. So here also in Unacademy, I am going to teach only the structural engineering subjects, ranging from engineering mechanics, strength of material, structural analysis, concrete structures, steel structures, and finally to construction methods and management. These six subjects of structural subjects I did. Right. Some people will also ask us, sir, okay, in addition to this one, what is the specialty of this university from where you had graduated? This university has produced six Nobel Prize winners, brothers. You can understand, producing six Nobel Prize winners from a university is not a joke, right? So that is the major, that is one great thing about this university, and the ranking of this university is always far better than IITs and IISc Bangalore. If you had seen any global ranking from the past 100 years, the ranking of this university is very far better than IITs and IISc Bangalore. One thing, right? And more some people will say like, sir, coming to your work experience, what you had done previously in addition to teaching? Other than teaching, I worked as research scientist or research engineer in University of South Carolina for a funded project. This funded research project, this is in USA. For the same project, I worked as a team lead also I worked, right? And previously I worked as head of the department of civil engineering in an engineering college called as 10, is in Andhra Pradesh, India. That means I have these two experiences in addition to teaching. Coming to teaching experience, I have teaching experience in GATE and ESE in different coaching institutes all across India. So maybe online and offline, if you take from the past 12 years, I am teaching continuously. And coming to some people will say like, sir, you are a structural engineer. Now what else you do? Being a structural engineer, even till today, I am working as an independent structural design consultant. I personally give structural drawings to my clients, and I personally give material testing reports to my clients. This is my brief background, brother. uh, okay. Some people will also say like, sir, you asked us to install this Unacademy learning app now. Okay, how to install that one, sir? Please, can you show with the help of a pictorial view? Yes, why not? This is after you type this Unacademy learning app in your what you can say, in your smartphone, or in your I can say in Play Store or App Store. You are able to install this Unacademy learning app from the Play Store. After you install this Unacademy learning app, you are able to see a screen on the right hand side in this way. So the installation is over. Now the question is, sir, how to follow you? Is there any other way that we can follow you other than this link? Yes, yes, you can do. This is the target what you want to achieve. You can select this target or goal what you want to achieve as maybe the GATE and ESE, or maybe the particular state PSU examinations, whatever that may be, you can keep. Okay. And here you go to free classes. I hope you know free classes. After you go to free classes, here in this main drop down menu, in the search button, you can type my name, Venkata Tilak Uppalapati. When you type this name Venkata Tilak Uppalapati, then definitely my profile is visible to you. When my profile is visible to you, you are able to follow me. You can follow me. When you are able to follow me, I hope you know the advantage that I already teach you, right? Some people will say, sir, okay, this is how we can follow you. I just had another question like, sir, how to take the paid course? Can you show us with the help of the screenshots? Yes, definitely. So after you had taken this, you select this target as GATE and ESC, and in this main drop down menu, the question is how to purchase a paid course. So in this main drop down menu, go to plus courses. After you go to plus courses, you are able to see a terminology called as get subscription. When you use this get subscription, when you press over this tab get subscription for paid course, it will be shown like what is the course that you want to purchase, whether iconic course or plus course. Select the course whatever you want to purchase. And to get 10% discount for iconic courses or plus courses, you are bound to apply the referral code VT10. When you apply this referral code VT10, directly 10% discount will come. Moreover, it shows your trust on me. Moreover, it shows your faith on me, and I can say it will directly connect between you and me. All your doubts will be redirected to me when you are able to use this code VT10. Right? Some people will say like, okay, sir, what are the advantages when I had taken the paid course? So coming to the first and foremost advantages, instant doubt resolution in addition to daily live classes. That is the first and foremost advantage the paid guys will have. The paid guys can directly talk with the educator through online chat, and they will resolve all they can resolve all their doubts instantaneously. So by the time class is going itself, that is the first and foremost advantage. Second advantage is support of test series is there. In order to crack any sort of competitive examination, test series support is required. We are providing test series in the form of live tests, quizzes, mock tests, grand tests, subject-wise tests. In the form of all these ways, we are providing the test series. You after writing these tests, you can understand at what level you people are in terms of preparation, and you can evaluate your performance. You can compare your performance with the topmost students of an academy. And if you want to improve your performance in particular subjects or in particular topics, you can work out more number of problems in that particular topic, and you can listen to more number of lectures in that particular topic. That's how you can improve your performance. Coming to third advantages, there is no need to plan yourself, as all the courses that are provided by an academy are completely structured courses. If you follow the plan that we provide you, definitely we are pretty much sure like you are able to crack any sort of competitive examination with very pretty good rank. There is no doubt at all, because you are able to complete all the subjects within the given way, and you will work out all the test series also, so which will make you ensure you like that you will crack the examination with very good rank. And coming to the fourth advantage is unlimited access will be provided to you when you have taken this paid course. When you had taken this paid course, let us suppose you are absent to one of the live class. In such case, you will be provided with the recorded version of the same class through the comfort of your through the comfort of the device. What you can access using for the device, you will be provided unlimited access to those lectures of live and recorded versions. So which make sure you all these four, which will make sure you to crack any sort of competitive examination with very pretty good rank. There is no doubt at all, right? So these are some of the topmost indicators that we have. You can have a look directly in the app. I just want to convey you that the courses will be taught separately in English medium and also in Hindi. So there won't be any language barrier also, brother. So the guys who are comfortable in English can go to English classes. The guys who are comfortable in Hindi, they will go to Hindi classes. There won't be any language barrier also. When you had taken subscription, you will be provided access to both the classes, a Hindi medium classes, and English and Hindi and English version of classes also. Some people will say, sir, till now in GATE and ESE, how many paid courses till now you people you had launched, especially in civil engineering? Especially in civil engineering, we had launched 8 courses. Out of these 8 courses, few courses are in English and few courses are in Hindi, and a few courses are in few courses are long-term courses, few courses are short-term courses. When you had taken subscription, brother, you will be provided access to all the courses that are launched by an academy in that particular stream. And in future, if let us suppose if some of the courses are launched, if you are in the duration, if you are still having the duration to access, in such case you will be provided access even to those courses that are being launched in future also, right? So now coming to the financials. So for 12 months course, the cost after 10% discount, this is the cost for plus courses. For plus courses, after 10% discount, it is 27,225. Where I can recommend this 12 months course for the students who are in final year. Whereas if the students who are in third year or second year, I can recommend this 24 months course to for second year and third year students. Where after After 10% discount, the cost for 24 month subscription is 39,600. If you want to get 10% discount for all the courses for whatever may be the duration of subscription, maybe I can say like maybe I can say from 1 month course to 24 months course. If you want to get 10% discount, you are bound to use this code VT10, and directly 10% discount will directly come to you on all the courses. So these are some of I just want to convey one more thing. Every day my class is happening in this Let's Crack GATE and ESE Civil YouTube channel. Every day my class is happening by 11 a.m. You people are welcome. You can refer the same thing to your friends, so they will also get benefited, brother, in this Let's Crack GATE and ESE. So please subscribe to our channel Let's Crack GATE and ESE Civil YouTube channel. You are getting all this for free of cost. Please share this video, like this video, subscribe to our YouTube channel, and don't forget to press the bell icon. If you press the bell icon, the future coming videos will be notified to you on this YouTube channel. For your comfort, I already started a Telegram group, and the name of the Telegram group is Unacademy underscore Civil Engineering Tilak. If you want to follow that group, if you want to come down to that Telegram group or Telegram channel, you can use the link which is given below. If you press over that link, it will be you will be redirected to my Telegram group. And if you had any doubts, you can post your doubts directly in the Telegram group. I will take care of your doubts directly there. Okay, so please raise a thumbs up, and please share this video just after this session at least. Right, so shall we start the session, brothers? Say yes or no. Right, so coming to today's session, in your previous session, I started in your previous session I started columns, and I teach you what is the load carrying capacity for a short column, what is the difference between long column and short column, I teach you. So I need to start working out the problems on short columns. Before I start working out the problems on short columns, I just want to convey. Some people had a doubt like, sir, how to find out the effective length for different columns? So the effective length for different columns, the definition for effective length also I mentioned in your previous class, which is the distance between two adjacent points of contour of flexure. If you take, this is how the deformation sketch is possible. So in effective lengths, there are two types of effective lengths. I can say one is theoretical effective length. Second one is practical effective length. Generally, the effective lengths that are tabulated in code of practice are generally these theoretical effective lengths. These are tabulated in code of practice. If you want to design where these practical effective lengths are useful, brother, these practical effective lengths are some bit higher than theoretical effective lengths. The practical effective lengths are slightly more than, slightly instead of increase I can say slightly more than theoretical values, theoretical effective lengths, right? Generally, in case of our design of concrete structures, generally in case of design of structure, generally we will use this practical effective length. These practical effective lengths are used in the design of structures. Why can't I use this theoretical effective lengths? In theoretical effective length, that is actually for theory, but in practical effective lengths, these are more, so we will be under safe side. So I can say for the safety concern, for the safety measurement, we for the safety concern, we use practical effective length for the design of structures, RCC structures, I can say, right? Especially if you take, I hope this value which is on the brackets, these are theoretical effective lengths. Generally, we call L effective theoretical length L over root 2. In this case, L over root 2, it is 0.707 times of L. and practical effective length L effective, I can say practical. It is more than 0.707 times of L, which is equal to 0.8 times of L. And coming to this is a fixed end, and here at this end this is a fixed end. When these are loaded with axial loads, in such case this is how the deformation sketch is, right? These are the points of two contraflexure, right? Isn't it or not? If you work out this practical effective length, this theoretical effective length, the theoretical effective length here is 0.5 times of L, whereas practically the effective length will be 0.65 times of L. So in bracket, these are theoretical, but without bracket, there are practical values. Generally we will use these practical values, brother. So this L zero point 0.7, so L practical, L effective practical, this is theoretical, right? So here, so like that, generally for the design purpose, by the time you are designing any sort of structure, use this practical effective length. Whereas if you are working out the load carrying capacity of a column for a given structure, in such case use this theoretical effective length. So, shall we start the problems, brother? So, coming to the first problem, right? Coming to the first problem, the factored load carrying capacity of a column of 300 millimeter by 600 millimeter size. 300 millimeter by 600 millimeter. So, take a factored load carrying capacity of a column. Take a column of 300 millimeter by 600 millimeter with minimum percentage of steel, but the minimum part with they are expecting the load carrying capacity of the column with minimum percentage of steel. So they didn't give you like whether it is long column or short column. They are clear, they are directly giving you it is a short column. For short column, how you can work out the load carrying capacity? So can you tell us what is the load carrying capacity of a short column? So to judge whether it is short column or long column, the length shall also be given. Because the length is not given, so directly we cannot judge it as short column and long column, and they are giving it as short column here in this case. But if they didn't give you the short column or long column, then definitely they must and should give you the length of the column also to work out its slenderness ratio. The slenderness ratio is more than 12, it is long column. The slenderness ratio is less than 12, it is short column. Right. So the load carrying capacity of column, it is load carrying capacity of concrete plus load carrying capacity of steel in compression. Load carrying capacity of concrete plus the load carrying capacity of steel in compression. What is the load carrying capacity of concrete? The load carrying capacity of concrete, if you take it, is the permissible strength of concrete in axial compression mode is FCK by safety factor for concrete in axial compression total overall is 2.5, I can say, into area of concrete, I can say, plus what is PSC, that is the load carrying capacity of axial load carrying capacity of steel, compression steel, which is the permissible stress is Fy by factor of safety is 1.5 for steel in axial compression. See, this 1.5 is the partial safety factor for steel, reinforcing steel in axial compression. So there is a lot of difference between axial compression and flexural tension, flexural compression. For flexural tension and flexural compression, the factor of safety for steel is 1.15. So this multiplied by area of steel in compression, ASC. So if you work out the grade of concrete is 20, na? So I can write 0.4 times of FCK, it is 20 into area of concrete. What is the area of concrete, brother? So out of this gross cross sectional area, AG is equal to 300 by 600. What is area of steel in compression with minimum percentage of steel? What is the minimum percentage of steel in concrete? 0.8 percentage of gross cross sectional area. So 0.8 percentage of AG, which is 0.8 by 100 into gross cross sectional area is 300 by 600. This is how we can work out, which is 1440 millimeter square. And area of concrete. What is area of concrete? How you can take, if you take grass cross sectional area, it is area of concrete plus area of steel in compression. How I can say the area of concrete alone, grass cross sectional area, will AG minus area of steel in compression, which is 0.8 percentage of AG. So in such case, definitely I can work out grass cross sectional area is 300 multiplied by 600 minus 0.8 percentage of grass cross sectional area, which is 1400, which you will get as 178560 millimeter square. So let me substitute these values directly in the problem, brother. Is that okay? Right? So can I substitute the values, brother? Area of concrete, it is 178560 in plus Fy. The Fy answer is I can say Fy by 1.5, which is 0.67 times of Fy. The yield strength of the steel is Fe415. I can use 415 into area of steel in compression. The area of steel in compression is 1440. So if you work out this one, then obviously it is 1828.87 into 10 cube. You are going to get this value as newtons. If I work out this in kilonewton, 1828.87 kilonewton. The nearest value is what, brother? The nearest value is 1829 kilonewton. So you can pick option C. Is that okay? This is how you can pick this option, brother. Right? Shall I move to the next slides, brothers? The next question. Is that okay? So if you are okay with this one, please say yes. Right. Hi, GPH both. How are you? Hope you are fine. Right? Yeah. So can I move to the next question, brother? Moving to the next question. This is how the next question is given. Right? Can you see this question? The ultimate load carrying capacity. The maximum or ultimate load carrying capacity of a circular section of 300 millimeter diameter. 300 millimeter diameter circular section is there. 300 millimeter diameter circular section is there with a helical reinforcement using 1 percentage of reinforcement. So they are saying the ultimate load carrying capacity of a circular section of 300 millimeter diameter. So the diameter of the cross section is 300 millimeter. Okay. With helical reinforcement, they are saying with helical reinforcement. When we do the design with helical reinforcement, then the load carrying capacity of the column can be increased by 5%. This I already mentioned in your previous class. What is the reason behind that one? Why I should increase the load carrying capacity of the column by 5%? If you take the design of any circular column with helical reinforcement, sufficient continuity is there. As the continuity of the column is there, more and more continuity of the column is there. So I can say effective confinement of the column is also more. As effective confinement of the column is more, then in such case its load carrying capacity of the column is also more. Right? That is the reason that I already mentioned in your previous class. Okay, right. If you take this section, circular section of diameter 300 millimeter with helical reinforcement. Okay. Oh, they are taking certain, they are using some but the number of bars they didn't mention, but still, certain bars I had taken 1, 2, 3. I am using 6 bars because the code says when it is a circular section, at least the minimum number of bars I need to use for the design of circular cross section is six number of bars. So that's the reason why I'm showing it as 6 bars. Okay, right. And the area of steel under what is the area of steel under compression? Area of steel under compression is 1 percentage of reinforcement using is 1 percentage of gross cross sectional area. So ASC is 1 percentage of gross cross sectional area, AG. how you can say 1 by 100 times of gross cross sectional area is pi by 4 into 300 square. This is how we can work out the area of steel in compression. After you work out this area of steel in compression, now the question is, okay, they are saying M20 concrete and Fe 4 on 5 grade steel. Now they had given area of steel in compression. What is the area of concrete, brother? Area of concrete is what total gross cross sectional area is 100 percentage. If 1 percentage is gone for main reinforcement, the remaining 99 percentage is area of concrete. So area of concrete is 99 percentage of gross cross sectional area. Can I write that one? 99 percentage of gross cross sectional area is 99 by 100 into gross cross sectional area pi by 4 into 300 square. This is how we can work out. And coming to the load carrying capacity, which is called as PU, this is a helical reinforcement, right? When it is helical reinforcement, the load carrying capacity must and should be increased by how much percentage, brother? The load carrying capacity must and should be increased by 5 percentage. So I can write 1.05 times of the load carrying capacity of the short column, which is 0.4 times of FCK into area of concrete in compression plus 0.67 times of Fy into gross cross section into area of steel in compression. This is the formula. Na? So fundamental formula, derivable formula. We had already derived that one. And if you do this one, when if you just substitute here 1.05 times of 0.4 times of FCK. It is M20 grade of concrete. So 20 into area of concrete. Area of concrete is 0.99 times of pi by 4 into 300 square plus 0.67 into Fy. Yield strength of steel. The yield strength of steel is Fe 4 on 5 into area of steel in compression zone. What is the area of steel in compression zone? Area of compression steel. I cannot say compression zone. Area of steel in compression. What is the area of steel in compression? I can write it as 0.01 into pi by 4 into 300 square. This is how I work out. If I work out why this to 1.05 it is multiplied, the circular column is having the helical reinforcement. As circular is column is having helical reinforcement, as per code we are increasing the load carrying capacity by 5 percentage. If you are able to work out, the answer is 794.2 into 10 cube Newton you will get. If I work out the same answer in kilonewton, the answer is 794 kilonewton. Is that okay? So the option directly we can pick is option D for Detroit. This is how you can work out, right? Can I move to the next slide, dear brothers? Dear VPH, both dear Vasan Sai or any other person who are on the online. Can I move to the next slide? Right. So can I move to the next problem? Moving to the next problem, brother. I hope you are able to see the next problem. In this one they are saying a reinforced concrete short column. They are clearly mentioning it is short column with 300 millimeter by 300 millimeter square is made up of M20 concrete and has four number of bars. They are saying so area they are saying gross cross sectional area is 300 square indirectly, right? And they are saying area of steel in compression. It is 4 bars of 24 millimeter diameter. So 4 into pi by 4 into 20 square, right? ASD. So, some value you will get. And after that one, they are saying Fy. That is Fe 4 on 5. Na? Fy is 4 on 5 megapascal Newton per millimeter square. It is under the action of concentric axial compression load. They are saying it is under the action of concentric. There is no concentric in sense. There is no eccentricity is zero. Concentric axial compression load. And they are saying it is eccentricity is zero. When eccentricity is zero, there won't be any sort of moments will come, right? So definitely. and ignoring the reduction in the area of the concrete due to steel bars. So reduction in the area of the concrete is ignored because of steel bars. So I can say area of concrete. Area of the concrete is directly given as gross cross-sectional area, which is 300 square. We can write in this way. The ultimate load carrying capacity of the short column. What is the load carrying capacity of the short column? They are expecting that. So can you work out the PU, which is 0 0.4 times of 0.4 times of FCK, which FCK is M20 grade of concrete. 20 into 0 0.4 times of FCK into FCK into area of concrete. What is the area of concrete? It is 300 square plus permissible stress of compression steel. What is the permissible stress of compression steel? In axial compression, 0.67 times of Fi. Fi is Fe 415 into area of steel in compression. What is the area of steel in compression? It is 4 numbers of 20 millimeter diameter bars. So I can write 4 into pi by 4 into d square. So I can write 4 into pi by 4 into 20 square. Is that okay? If you work out this answer for PU will be definitely 1069.41 into 10 cube Newton, which is equal to 1069.41 kilonewton. So directly the answer is option D is the suitable answer that you can pick here directly. Is that okay? Right? Can I move to the next problem? Some people will also ask us, sir, if the data is given, how to ascertain whether the column is long column, whether the column is short column. Such type of question we are going to deal in the next level, right? So moving to that problem, I hope you are able to see this problem. A column of 600 millimeter by 450 millimeter. Let me take a column of dimensions, RCC column of one is 450, another one is 600. Let me take a column of this time. This is 450. This is 600 millimeter. The effective length of the column, they had clearly given like effective length of the column is 3 meter, right? And the design criteria of the column as per IS 456. How you can design the column? Short, I can say what how you can consider. So with respect to long dimension and with respect to short dimension, there are two axes are there here, brother. I can show you here. So with respect to this axis may be z axis, with this axis may be y axis. So with respect to z-axis, what is the slenderness ratio? So slenderness ratio with respect to shorter dimension, slenderness ratio with respect to longer dimension, I can say. So I can say LE by slenderness ratio with respect to y-axis, the least lateral dimension is 459. LE by B value. If you take LE by B value, LE is already 3 meter, which is 3000 millimeter by B, the least lateral dimension is 450. So this is millimeter. I just want to convey LE by B. This is the slenderness ratio with respect to uh, shorter dimension, right? Uh, Now some people will say like, sir, if you work out this one, this answer is 6.67. Generally, when the slenderness ratio LE by B is less than 12, it is short. So with respect to shorter dimension, least lateral shorter dimension, the slenderness ratio of the slenderness ratio of the column is less than 12, so it is short column. It is short. Now I want to work out the same slenderness ratio with respect to this is slenderness with respect to shorter dimension or with respect to y-axis. Right. Next, slenderness ratio with respect to uh, long dimension of cross section, or we can write with respect to z-axis. With respect to z axis, if I want to consider, then in such case it is LE by, with respect to z axis, the least lateral dimension is this much. This is the lateral dimension for z axis. It is 600. So LE by 600, I can say LE is 3000 millimeter by 600. If you take, the answer will be 36 30 by 6, so the option is 5. And this value of LE by least lateral dimension, this value is also less than 12. So even with respect to shorter dimension, even with respect to longer dimension, the the classification of the column is termed as short column only, right? It is short column. So even with respect to long and even with respect to short also, these are so I can directly write like short along long, short along long, and short along short dimension. So I can say it is both, it is short column we can classify, right? Sir, hi, Dhiman Shiv. Sir, when you will be when we will be your course on plus start? Dear Dhiman Shiv, by the time they mention me to take that plus course, by the time till now there is no notification for me like when I should take. They will definitely tell me at some time. The time will be given to me. By the time I will definitely let you know, dear Dhiman Shiv. Okay, right. Right. So is that okay, brother Shiv? So this is how you can work out. So shall I move to the next question or next problem? Moving to the next question or next problem. I hope you are able to see this question, right? A reinforced concrete column contains longitudinal steel equal to. So they are saying area of steel in compression zone, which is longitudinal steel or longitudinal compression steel. It is 1% of net cross sectional area of column. So 1% of area of concrete, I can say 1% of area of concrete. Net 1% of net cross sectional area of column. Net cross sectional area of column means area of concrete, right? Net cross sectional area of column is nothing but area of concrete in compression. So I can say 1% of AC. And assume they are assuming they are here giving the modular ratio M. M is equal to modular ratio, which is taken as in limit state method. It is the ratio between Young's modulus of steel to Young's modulus of concrete. So which is it is given as 10. In such case, the loads carried. What are the loads carried using the elastic theory? Using elastic theory, the loads carried. What is the load carried? By the longitudinal steel. Load carried by the longitudinal steel, and the net area of concrete are longitudinal steel is PS, and net area of concrete is PC. So load carrying capacity of concrete is PC. Load carrying capacity of concrete alone. PS, load carrying capacity of steel. Load carrying capacity of steel. They are expecting what is the ratio of this load carrying capacity of steel by load carrying capacity of column. So how you can deal this one? Generally, if you take the generally, you can work out the total load carrying capacity of the column, right? So but how you can work out the load carrying capacity of steel by load carrying capacity of car? I hope you know limit state. I hope you know strain compatibility in case of RCC columns. If you take an RCC column in this way, right, how much is the axial strain for concrete? The same is the axial strain for steel. Will you accept? These are steel rods, for example. These are steel rods. So I can say I can use a compatibility condition, like compatibility condition. strain of axial strain of concrete is equal to axial strain of steel. Axial strain of concrete is equal to axial strain of steel. When both axial strain of concrete is equal to axial strain of steel, then what you will get? So if the strains are equal, the change in dimension, because the lengths of this concrete and lengths of the steel rods are also one and same. In such case, you can understand the change in length of concrete is equal to change in length of steel. So I can say like delta L of concrete is equal to delta L of steel. This is how we can say, right? Now, how you can write delta L of concrete? Change in length of concrete. We can write it as concrete change in length. How you can? This is axial. This is axial change in length. So the change in length of concrete we can write as delta L is equal to PL by AE. Na? So in the same way here it is change in length of concrete. So I can write PC into length of concrete. Maybe I can say LC by Young's modulus of concrete, EC into area of concrete. Can I write AC? So here it is delta change in length of steel. I can write the resisting capacity, axial resisting force in steel into length of steel by Young's modulus of steel into area, cross sectional area of steel. This is how you can work out. And you know the length of concrete is equal to length of steel for a column, because whatever may be the length of concrete is equal to length of steel here rods. So definitely I can clearly write here these two can get cancelled, no doubt at all, right? And coming to area of steel in compression, ASC, how you can write this ASC? I can write this ASC. This is PC by EC is equal to PS by ES into ASC. I can write as AC by 100. Can I write this one as Can I write this one as AC by 100, because it is area of steel in compression is equal to 1 percentage of area of concrete, which is area of concrete by 100. This is how I can write. After I write this one here also AC. AC has got get cancelled. Here if I work out this PS by PC, I will end up with PS by PC, I will end up with percentage. Point one is the ratio. What is the thing in terms of percentage, brother? In terms of percentage, how we can write in terms of percentage? I can write it as 10 percentage, right? Right, right. So PS by PC is equal to point one. PS by PC into 100 is equal to point one into 100, which is equal to 10 percentage. So like that we can keep option D for that, right? Is the correct option. Is that okay? Right? Can I move to the next slide? I mean next question, or maybe the next concepts, if you please say, right? Is that okay? Right. Moving to the next concept, or next concept. Some people will say, sir, if you take the effective length for a column, if it is a single column, I can work out. Generally, people will have a thing like, sir, effective length for single columns, length for a single column can be worked out from tabular form of IS 456 2000. Now some people will ask me a question, sir, if I want to work out the effective length of a column in case of a framed structure. I hope you know, let us suppose a framed structure is in this way clearly. This is the framed structure. If for example, if I want to work out the effective length of this column, for example, this column here, for this column, if I want to work out effective length, in such case, how I can exactly work out the effective length of this column, which are subjected to especially this lateral loads. I hope you can say these are lateral loads. In such case, I just want to convey how to work out the effective length of columns in case of framed structure. And some people will also ask like, sir, in case of RCC structures, At a support, if I want to get bending moment as 0, how I can bend the structural steel? The bending of the structural steel should be in this way, brother. I hope clearly you are able to see. Here I want to make the bending moment as 0. How I can make the bending moment as 0? If the steel reinforcement coming at the mid level of the section, the steel reinforcement is coming at the mid level of the section in this way. If I bend the steel in this way, then generally this point will act as a hinge. How and why this point will act as a RCC hinge? How you can introduce a hinge inside an RCC? This is how, if you bend the steel reinforcement, this point will get introduced as an RCC hinge. Because here, if you take at this point, the compression steel or tension steel, whatever that may be, both the compression steel and tension steel, both the lever arms are acting at the same point. So in such case, here at this particular point, lever arm between two steel reinforcement is 0. So obviously moment of resistance here, it is 0. So moment carrying capacity at this section only is 0. Sir, Mukul Nandan, sir, what is the use of modular ratio? Dear, 1 second. I hope, dear Mukul Nandan, the use of modular ratio is, if I know the modular ratio, then I can convert the stresses of steel to concrete. If I know the stresses of concrete, I can convert the stresses of concrete to steel. So I can say simply here, modular ratio, use of modular ratio. If I know the stress in concrete, if I know the stress in concrete in a section using modular ratio, I can find stress in steel. Because if you take generally the modular ratio, which is the Young's modulus of steel to Young's modulus of concrete, so it is indirectly, it is stress developed in steel, this is stress developed in concrete. Indirectly we can write this one. Generally this modular ratio is very much useful, to convert the stresses from to convert the stress from steel reinforcement to concrete reinforcement, especially in case of working stress method, right? Is that okay, Mukul Nandan? So if you learn this concept of working stress method, about the equivalent area of concrete section for a steel area, so in such case that is useful. So I can say here, even uh, to convert steel area into equivalent area of concrete. So if you take this one, this is the area of we can write this is area of steel by area of concrete. In this way also people can write, because stress is equal to P by A na? So directly we can also write even in this way, and we can convert the steel area into equal area of concrete also. Right, that type of application you will see generally at the time of working stress method, brother. Right. Now coming to this question, coming to our limit state method here. Okay, I am much more interested to find out the effective length of these columns in framed structure. How I can work out the effective lengths of columns in framed structure? Yes, there are some certain guidelines were also given in IS 456 for these framed structures, like uh, in appendix charts, Woods charts in appendix of IS 456 were given were given to find effective length of column, right? Now the question is, sir, okay, sir, effective length of the column is, I just want to convey one more thing here. I will show those charts also. From the chart, how we can work out the effective length also, I will show. It's not at all a problem. But let me tell you one thing, right? The effective length of the column is independent of load acting on the column. So how much amount of load that is acting on the column? So that amount of load acting on the column is independent of effective length. So maybe higher load or lower load, it doesn't matter. But this effective length of the column is only is dependent on end or support conditions. I can say stiffness of the joints, right? Stiffness of members of column, comma, stiffness of joint, right, etc. And I can say it also depends on end conditions or support conditions, stiffness of the column. And this effective length also depends on, I can say, the dimensions of the column, the dimensions. Not dimensions. I can say effective length cannot be dependent on dimensions. So the effective length is dependent on these two parameters, brother. Okay, let me show you. Let me show you how we can work out the effective length from these Woods tables that are given in charts of. If you take clause E, I mean, if you go to appendix E, appendix E, Wood. The name of the scientist is Wood. Wood has proposed certain tables. Wood has proposed tables to find the effective length of column to length of column, where man, to find the effective length of column in a framed structure, in a framed structure, or I can say rigid jointed framed structure, rigid jointed framed structure. It depends on, to work out the effective length of the column, it depends on two coefficients, beta 1 and beta 2. I will show you what is this beta 1 and beta 2. I just want to convey in this figure 26. This figure 26 is used to find out effective length of braced columns, or braced columns. I will let you know what is braced columns. Figure number 27 I can use to work out the effective length for unbraced columns. Unbraced columns. So in these figures 20, 26 and 27, there are two terms are there, beta 1, beta 2, which represents the degrees of rotational freedom at the top and at the bottom ends of the column. If degree of rotational freedom, what do you mean by degree of rotational freedom? Degree of rotational freedom depends on I can say flexural stiffness of joint, flexural stiffness of joint. I hope at a rigid joint, if there are n number of members are meeting, from your concepts of structure analysis, I hope you know the concepts of structure analysis. From the concepts of structure analysis, let us suppose this is O, this is A, this is B, this is C, D. So at this joint is O. At this joint A, it is maybe hinged. At this joint B, it may be fixed. At this joint C, it may be fixed. At this joint D, it is certain something like free. So how you can work out the rotational stiffness of this joint? Rotational stiffness of the joint is equal to rotational stiffness or flexural stiffness or rotational stiffness. It is equal to sum of the sum of the rotational stiffness of all members meeting at a joint. Of all members meeting at a joint. I hope you had learned in your structural analysis program, especially if this is near end, if this is far end, if the far end is fixed, what is the stiffness of flexural rotational stiffness of this beam with far end is fixed. If the far end is fixed, the rotational stiffness is 3 EI by L. So if the far end is hinged, then if the far end is fixed, sorry, it is not 3 EI by L, it is 4 EI by L. It is 4 EI by L, right? If the far end is hinged, so it is far end is fixed. If the far end is hinged, it is 3 I by L. So like that, the stiffness for different beams, rotational stiffness, if the far end is free, then the value of K is 0. So like that, based on degree of rotational freedom, which depends on flexural stiffness of the joint, which is equal to sum of the rotational stiffness of all members meeting at the joint, which is in this figure, if I can say, it is stiffness of OA plus stiffness of member OB plus stiffness of member OC plus stiffness of member OD, right? Like that we can work out based on this rotational stiffness. If the stiffness is high, if the rotational stiffness is high for structure, its rotational capability is less indirectly. Like that we can mention. I just want to convey using this beta 1 and beta 2. I will show you these ones. We are able to work out the effective length. Let me show you with some people will also ask us before you show beta 1 and beta 2. First of all, you tell me what is the difference between a braced column and unbraced column. Let me tell you the difference between braced column and unbraced column. First, then I will show you that one. So what is a braced column? Let us suppose if this is a framed structure, brother. If this is a framed structure. Now, because of this lateral loads, if the lateral drift or this lateral displacement between one column to another, between one end of the column to another end of the column, if the lateral displacement delta is made as 0 or it is very less. In such case, the lateral displacement or lateral forces can be resisted very good by going with the help of bracings in this way, cross bracings. Whenever this relative displacement between the bottom end and top end of the columns are 0, then the relative displacement between the top end and bottom end of the column is 0 or very less. In such case, then I can say the column is called as braced column. Is called as braced column. In braced column, relative displacement between top end and bottom end of column is 0. How we can make that as 0? By providing these bracings. These are bracings are elements which will resist these lateral loads especially, right? Such things are nothing but braced such things such columns are nothing but braced columns. Here I had also mentioned clearly, if the lateral supports are provided, if there are saying if the lateral supports are provided at the ends of the column, the lateral loads are resisted by these lateral supports. In such case, such columns are nothing but braced columns. Indirectly, how you can say these braced columns? When relative transverse displacement between the upper and lower ends of the column is prevented. Maybe the upper and lower ends of the column is prevented. For that one, maybe if I had made in this way, the horizontal displacement or lateral displacement of this framed structure was stopped, and the horizontal displacement of this frame, when this lateral displacement of this framed structure was stopped, in such case by providing at this end in this way, in such case such type of columns are nothing but braced columns. In braced columns, the relative displacement between top end and bottom end of the column will be definitely 0. Now some people will say, sir, what are unbraced columns? What are unbraced columns, brother? I hope you can say, when the lateral loads have to be resisted by the other columns in addition to axial loads and end moments, there is no other way. Only single columns itself, with the help of columns and beams only, if the columns are able to resist the lateral loads, there are no other cross bracings are there. In such case, such type of columns are nothing but unbraced columns. Example for unbraced columns is, if I had taken a framed structure in this way, only beams and columns in this way. Now, because of this lateral loads, here this structure can move sidewards in this way. structure can move sidewards in this way. Structure is able to move sidewards in this way, then you are able to understand like, okay, there is a relative displacement. If you take this column at the bottom, the relative displacement, this displacement is delta. At the top, the displacement is very high. There is a relative displacement between bottom end and top end. Here in this case, this type of frames are nothing but I can say unbraced columns. Indirectly, I can say are sway frames. Unbraced columns are indirectly or non-sway frames in non-sway frames or the unbraced columns in sway frames. This is how you can understand. Now the question is, sir, okay, this is fine, sir. How I am able to work out this effective length? I just want to convey. I hope you are able to see the figure 26. From figure 26, I can find out the effective length for no sway frame. With no sway means for braced column. For figure number 27, I can deal with for unbraced column. For unbraced column. Right. Now the question is, okay, now if you take, if some people will say, sir, how to work out this beta 1 and beta 2? This beta 1 and beta 2 are the rotational capacities at the top and at the bottoms of the columns. How to work out the rotational capacities at the tops and at the bottom of the columns? Maybe if I take a frame, this is how. Right. Now coming to this beta one, this is sigma kc by sigma kc plus sigma kb, where the summation is to be done for the members framing into the joint. If this is top, for example, if this is bottom, this is a non-sway frame. For example, you take it as non-sway frame. In such case, what is this sigma kc stands for? Sigma kc stands for at this top or summation of sigma kc stands for flexural stiffness of the column. I hope you know summation of flexural stiffnesses for the columns. How you can work out the flexural stiffnesses for the column? If this is a column, if this is top end, so how many columns are there at this top end? This is one column and this is another column. Two columns are running. So sum of the flexural stiffness of the columns at the at that end divided by sum of the sigma kb at that point. The what is the sum of the flexural stiffness of the B? This is beam and beam. Maybe this is B1, this is B2, this is column 1, this is column 2. So sigma kc I can say like it is sum of the stiffness of the columns C1, sum of the flexural stiffness of column C1 and C2. So the flexural stiffness of the columns is depending on their end conditions. So we can say the flexural stiffness as maybe 4EI by L or 3EI by L depending on whether the far ends are hinged or whether the far ends are fixed. You know those conditions. Now, so I can say like sigma K1, it is the flexural stiffness of column 1, flexural stiffness of column 2. This is sigma Kc. What is sigma Kb at the top? At the top here, two beams are meeting, right? At this top, for example. So I need to work out flexural stiffness of these beams B1 and B2. What is the flexural stiffness of these beams and B1 and B2? It depends on their end conditions. So I can say flexural stiffness of beam B1 plus flexural stiffness of beam B2. If you are able to work out sigma Kc and sigma Kb by working out beta 1 and beta 2, you can work out at the top. If you work out, it is nothing but beta. You top, if you work out, it is nothing but beta 1. At the bottom, if I work out, it is nothing but beta 2. Right. Generally, for symmetrical structure, beta 1 is equal to beta 2. Both are 1 and same. Let us suppose, for an example, if it is a braced structure, beta 1 and beta 2 are 0.5, for example. Beta 1 is 0.5 and beta 2 is also 0.5. I hope you are able to. And both the beta 1 beta 2 are zero point 0.5, where these two are meeting here. These two are meeting at the point which is between 0.65 to 0.7. So what is this effective length? These are the effective length curves. The effective length curve where over which it is meeting is effective length by L value is, it is the average of 0.6675 plus 0.7 by 2. So I can say take it as 0.6875 indirectly. After I work out 0.6875, so I hope you can work out this effective length. Coming to this effective length, 0.6875 times of the length. From this one, I am able to work out the effective length for that particular column, especially in case of framed structure. So I just want to convey, if it is a normal column, single column, in such case, there is no need to go for this Woods table. If it is a framed structure, I need to go for these Woods tables. Table number 26 and 27 are proposed by the scientist Woods to work out the effective length of the column, right? So this is for braced column. This is for unbraced column, right? Now some people will say, sir, what is the slenderness limits for column? I mean, what is the maximum slenderness limit for column? I can say that unsupported, if this is a column is there. This is a beam you take. This is a column you take. And again, this is a beam you take. Right. I hope I just want to say this is beam, column, this is beam in a floor. If you take it this way, I hope you can say this distance is nothing but unsupported length. Unsupported length between two end restraints. This is one end restraint and this is one end restraint. The unsupported length between two end restraints, the unsupported length L by L should not exceed, L should not be greater than 60 times the least lateral dimension. 60 times the least lateral dimension. The least lateral dimension should be generally taken as B, right? So this unsupported length should not be greater than 60 times the least lateral dimension. That is the first and foremost slenderness limits for column. And let us suppose some people say like, sir, when it is a cantilever column, sir, for example, when if I take a cantilever column, maybe one end of the column is this is restrained, another end of the column is unrestrained. That means there is a beam is here, maybe I can say there is a beam or something is here, but there is no beam, it's a free end. When one end of the column is unrestrained, in such case its unsupported length is, if L is the unsupported length L, right, then this unsupported length L, in case of one end is unrestrained, this L shall not exceed, I can say shall not exceed 100 b square by t. What is b here? B stands for width of the cross section. B stands for B stands for width of cross section, or I can say B stands for width of the cross section or least lateral dimension. Then D stands for depth of the cross section. So this is the limit. The first clause is the limit when for column both ends are restrained. For second one, this can be applicable for column when one end is unrestrained. When one end is, I can say, unrestrained. Another name for unrestrained is when one end of the column is free. In such case, we can work out. These are the two clauses, brother. So by the time of design, please make sure like the column while that you had designed should not cross its limiting slenderness ratios also. Please be aware of this, right? And some people will say like, sir, you mentioned the slenderness ratio limits for columns, and so can you tell us what is the what is the spacings generally we can go for at max? right? If you take the specifications for stirrup reinforcement, coming to I can say, what are the specifications for stirrup reinforcement? Specifications for stirrup reinforcement. What are the specifications for stirrup reinforcement? That I hope you know what is stirrup reinforcement. Stirrup reinforcement are nothing but I can say lateral tie reinforcement. Lateral tie reinforcement. Spacing between lateral ties is yes. Spacing between lateral ties is yes. For example, if the longitudinal bar diameter is if the diameter of the longitudinal bar is phi1. Coming to the longitudinal bar diameter shall not be less than 12 mm. That you already this I already teach in your previous class. Now coming to the stirrup diameter, the diameter of the stirrup. If phi2 stands for diameter of stirrup, the diameter of the stirrup should not be less than one fourth of diameter of the longitudinal bar. Diameter of the longitudinal bar is phi1, and this phi2 diameter of the stirrup phi2 for stirrup diameter shall not be less than 6 millimeter. So this is how we need to select the diameter of the stirrup. If the diameters of the stirrups are even less than this one, then in such case the problem of I can say corrosion can happen very easily, and I can say uh, proper confinement is also not possible. So that's the reason why IS 456 has given these clauses to give the minimum provide the minimum diameter of stirrup reinforcement. Now the question is, sir, okay, you had mentioned the diameter for syrup reinforcement, that is fine. What is the spacing? What is the maximum spacing of this lateral tie reinforcement? What is the minimum spacing of this lateral tie reinforcement? I just want to know that one. Yes, coming to that one only. So coming to the next class, it is the pitch. We can call this spacing of this lateral ties. It is nothing but we call it as pitch of lateral ties. Of lateral ties. So coming to the pitch of lateral ties, yes. How we can work out that pitch of this lateral ties? We can work out the pitch of this lateral ties by using this maximum pitch and minimum pitch. I hope you can take the clauses here. The pitch for this lateral ties. It was clearly mentioned like the pitch for lateral ties. We call it as S. Yes value shall not be more than I can say shall not be more than I will say three values. Out of those three values, the minimum value I need to consider. The first value is least lateral dimension of the compression member. The least lateral dimension of the compression member is generally I can talk it as B. So B, which is the least lateral dimension of column, and this value of pitch should not be more than, or I can say should not be more than, I can say it should be minimum of 16 times the smallest diameter of the longitudinal bar. What is the diameter of the longitudinal bar we had provided? The diameter of the longitudinal bar is defined as phi1. Phi1 is diameter of longitudinal bar. If in longitudinal bar, if different diameter of bars are used, generally I need to consider 16 times the smallest longitudinal diameter of bar. Phi of smallest longi bar, and I can say this should not be more than 300 millimeter. Out of these three, whatever may be the minimum value, I need to fix that as pitch, that as the max, that as the pitch, right? Now coming to that is nothing but that is nothing but I can say pitch, maximum pitch. Out of these three values, the minimum value I need to fix that. Now some people will come and say like, sir, okay, what about this? What about this? What about this pitch in case of helical stirrups, sir? The spacing of stirrups and helical reinforcement requirement in columns. I had teach you the pitch for this stirrup reinforcement or lateral ties. Stirrup reinforcement or lateral ties. Now some people will come and say, sir, if the column is a circular column in this way, which is shown here, if the column is circular column in this way, the figure is not that much good, but you can see this figure. How I am saying all these ones, if you refer to the code of practice number SP34, where how to detail, it is the guidelines on detailing of RCC elements. Guidelines for detailing of RC structural elements. Guidelines for the design of RC structural elements. Right. So if you see that one, now the question is, what is the spacing requirements, especially for this helical reinforcement? So I can say for helical reinforcement, if you see, the answer is directly given in the sheet itself, I mean in the figure itself. This is the area where you can see about the pitch for the helical reinforcement. Let me zoom it, I mean zoom in sense, let me redraw it here. If this is how the pitch, this is how the circular ring has got came. So this is the pitch. When this is the pitch, we people call it as P. Its value of pitch in case of helical reinforcement should not be greater than 75 millimeter, should not be less than 25 millimeter, and should not be greater than 1 by 6 times of diameter of the core. I hope you can say 1 by 6 times of diameter of the core. What is the diameter of the core? This is nothing but the diameter of the core of concrete with the, which is in between these stirrups, which is in between the stirrups, that is nothing but D. So D stands for dia of core concrete. And I can say this value of this pitch shall not be less than 3 times of the value of this pitch shall not be less than 3 times of dia of stirrup. So if you are able to follow these 4 guidelines, you are able to fix the maximum pitch for helical reinforcement and minimum pitch for helical reinforcement. In between, you need to fix the spacing, or I can say the pitch, where P stands for, here I cannot say spacing, here P stands for the pitch. P stands for pitch of helical reinforcement. And minimum cover to longitudinal reinforcement. What is the minimum cover to longitudinal reinforcement? The minimum cover to longitudinal reinforcement is taken as 40 millimeter. So columns for columns, the minimum cover to longitudinal reinforcement is 40 millimeter is the minimum clear cover. So you don't try to keep a clear cover for clear cover for columns less than 40 millimeter. If you keep less than 40 millimeter, then there is a problem of durability will come. Code clearly says like you need to keep the minimum clear cover to columns is 40 millimeter in any case. Is not millimeter, yes, right. And some people will say like, sir, okay sir, we had seen the what I can say, we had seen certain clauses on this uh, s- we had seen different clauses on this columns. Okay, now if you take a short column, right, how to orient the column, I mean orientation of the column, I just want to talk. How you can talk about the orientation of the column? Orientation of the column means how to keep the dimensions of the column. Of course, if you take generally, if the column is a rectangular column in this way, this is how, maybe this dimension is B, this dimension is D, least dimension is B, higher dimension is D. In which direction? I mean, if beams are running in this way and in this way, if the column is needs to be kept is here and here, how you will run this orientation of the columns? I can say the orientation of the column is The higher dimension of cross section should be along longer span of beam. For example, here if you take this is a longer span, this is shorter span. There this is B. This may be certain 200. This is maybe 300. As the as a higher dimension of the cross section should be along the longer span of the beam. This is the longer span of the beam in this direction. So in this direction only, this higher span of 300 millimeters should be there. As in shorter direction, shorter dimension of the column can exist. So if you do in this way, the moment carrying capacity will also be sufficient. Now some people will come and say, sir, if you take a beam in this direction and this direction, the beam spans are one same. This is L1 and this is also L1. And in such case, if the column dimensions are something like, if the column dimensions that I had taken is this is 200, another one is 300, sir. How you can keep in such case? The answer is very simple. The answer is, if the column is of category C, in this type of category C with equal moments on either side, this is having for this column C, with respect to left side of the slab with respect to right side of the slab, the moments are equal and opposite. Then how we need to orient this column C? The orientation of the column C shall be based on the sway of the building frame. If you take the lateral, how the building frame can sway? When the lateral loads are in this direction, here for the columns are in this way, this is more stiffer side, I can say. More stiffer side. This is less stiffer side. Because if I keep the loads in plan for lateral loads in this way, this is able to move laterally, I mean in this direction. If I take, let me show you, this is X and this is Z. From this one I can say along Z axis or in Z direction, it is the sway of the frame existing. The critical sway for the frame is possible along Z direction. The critical sway for frame is possible along Z direction. So in such case, along Z direction, if I want to reduce the lateral deformation or sway, in such case along Z direction, I need to keep the higher side of this column dimension. That's how I can decrease. That's how I can decrease the sway in the frame, right? Now coming to, yes, for today, as you say, for today, I just want to stop this session, right? Before I end the session for today, I just want to convey one more thing, like uh, if you are a serious aspirant of GATE or ESE or any other competitive examination, in such case, I can definitely recommend you guys to take this paid course in an Academy learning app, especially in an Academy Plus, with this help of this code we written. For 1 month subscription to 24-month subscription, for any subscription, if you want to get 10% discount, you are bound to use this code VT10, one thing. And I just want to convey one more thing, like if it is a 12 month subscription, the cost after 10% discount is 27,225. If it is a 24-month subscription, the cost after 10% discount is 39,600. So for any of the course, if you want to purchase with 10% discount, you need to use this code VT10. When you use this code VT10, directly it will connect between you and me, and it shows your trust on me also. Moreover, I just want to refer this 24 months for the students who are in second year or third year. If you people are in second year or third year, I can recommend you this 24-month subscription. If you are in final year, I can recommend you this 12-month subscription, right? Some people, every day my class is happening in this Let's Crack Gate and ESE Civil YouTube channel. Every day my class is happening every day by 11 a.m. Every day my class is happening in this Let's Crack Gate and ESE. So please be aware of that one, and please come down to my sessions every day by 11 a.m. And I just want to convey, you are getting all this for free of cost, most of these important topics. So you inform the same thing to your friends, so that let them also get benefited. Please ask them to subscribe to our channel, Let's Crack Gate and ESC Civil YouTube channel, and please subscribe to this channel. Don't forget to press the bell icon. If you press the bell icon, the future coming videos will also be notified to you, right? And please give a thumbs up, please raise a thumbs up, so that we can do more free content for you guys in future. And please share this video, so that your friends will also get benefited, because these are free videos. At least your friends will get benefited. I just want to convey, there is so much of free content is already happening in Unacademy learning app. So if you didn't install till now, please install that Unacademy Learning app and come to those sessions in the app also. Some sessions are for free there. You can even come down there also, right? So I just want to convey one more thing. Like, I already started a Telegram group for you guys, especially to support you. The name of the channel is Unacademy underscore Civil Engineer Tilak. And if you come down to this channel, definitely if you had any doubts, you can post your doubts and I will take care of your doubts. Okay, right. So end of this session for today. If you please excuse me, end of the session.